Now that we've learned the product rule, now we're going to learn the quotient rule. So the product rule we use when we're taking the derivative of two functions that are being multiplied together. The quotient rule we use when we're taking the derivative of two functions who are being divided. So as long as the two functions are differentiable, then their quotient is also differentiable. And the way we're going to find the derivative of their quotient is taking and using this formula here, which is the derivative of the first times the second minus the derivative of the second times the first, all over the second squared. So if you remember from when I gave you the product rule, I said I like to switch it a little bit from what the book does. This is why, because notice that the way I use the product rule, I say for the product rule, the derivative of the first times the second plus the derivative of the second times the first. So by putting the product rule that way, I don't have to memorize anything really new for the quotient rule. I just have to know that instead of plus, it's minus in between, and then I also have to remember to divide by my second function squared. So let's look at a couple examples here where we use the quotient rule. So in the first example, I notice that I have a quotient. I have a linear function on top, a quadratic function on the bottom. So first thing I'm going to do is label all the parts I need. Well, I need f of x, my first function, or my top function, which is f(5x minus 2). I also need the derivative of my top function, or my first function. Well, the derivative of 5x minus 2 is just 5. I need my bottom function, g of x, x squared plus 1, and I need the derivative of my bottom function, 2x. So now, calculating the derivative of my given function, I get y prime is the derivative of the first times my second function minus the derivative of my second times my first function, all over my second function squared. And my second function was x squared plus 1. Well, I'm going to go ahead and clean up the top a little bit because possibly some things will combine or drop out. I'm going to leave the bottom. I don't see any benefit to me foiling that out. So on top, I'm going to have 5x squared plus 5 minus 10x squared plus 4x all over x squared plus 1 squared. Well, then cleaning up the top by combining like terms, I get a final result of negative 5x squared plus 4x plus 5 all over x squared plus 1 squared. Looking at my second example, so as I had said before with when you watched the video on the product rules, I gave you a bunch of formulas for trig functions. So I'm going to show you how each of those are derived by showing you how to find the derivative of tangent. I could, in a very similar manner, find the derivative of secant, cosecant, or cotangent. So when I go to find the derivative of tangent, the first thing I'm going to recognize is that tangent of x is the same thing as sine x over cosine x, and that's that's a quotient. So since it's a quotient, I'm going to use my quotient rule. So my top function, or my first function, is sine x, and the derivative of that function is cosine x. My bottom function is cosine x, and the derivative of my bottom function is negative sine x. Well, so then the derivative of tangent of x, so the derivative of tangent of x is going to be equal to the derivative of the first times the second. So I have cosine of x times cosine of x. So I'm going to go ahead and say that's cosine squared x minus the derivative of the second times the first. So I have minus sine x times sine x. So that's going to be a negative sine squared x. So I'm going to say that becomes plus sine squared x all over my second function squared, so all over cosine squared. Well, I know that cosine squared plus sine squared is 1. That's one of my Pythagorean identities that we learned last year. So I get 1 over cosine squared x, which is the same thing as saying secant squared x, which is the definition I gave you. The derivative of tangent of x is secant squared x. So as I said before, if I wanted to show how I can find the derivative of cosecant, I would say, well, cosecant is 1 over sine, and then use the quotient rule with that. How do I find secant? Well, the secant is equal to 1 over cosine, therefore I can use the quotient rule to find the derivative of that. So kind of one less thing to memorize if I can just know and understand how to derive these derivatives. And then looking at our third and final example here, again, I notice it's a quotient, so I'm going to use my quotient rule. I'm going to say my first function is 2x, and the derivative of that is just 2. My second function is x cubed minus 1, and the derivative of that is 3x squared. So then the derivative of my given function is the derivative of the first times the second, so 2 times x cubed minus 1 minus the derivative of the second times the first, all over the second squared. So again, I'm going to go ahead and clean up the top. This time, because it is so simple to square the bottom, I'm also going to go ahead and square the bottom. So now I'm going to have 2x cubed minus 2 minus 6x cubed all over 9x to the fourth. Well, on top, combining my like terms, that gives me negative 4x to the third minus 2 all over 9x to the fourth. Remember, I can't reduce because my second term up on top does not involve any x's, so that will be the derivative for f of x. And that is all for the quotient rule. In class tomorrow, we will look at some examples on when you can skip the quotient rule, similar to what we looked at when you can skip the product rule.